Okay, lecture 10, we'll talk about sterile filling, stoppering, and sealing process. So you can see this picture showing you the filling operation. Probably it is taking place inside of some kind of isolator. So if you click on that web link, you'll see YouTube video, which is pretty outdated because now it's Catalan, but used to be Cook Pharmica. They made this video showing you their filling capacity or filling operation there. You probably cannot hear this sound, but showing you the filling isolator with the filling machine inside. Okay, see the glove compartments all sealed up. I think it's during the line clearance because the operator is inside of the filling machine right now. They are not supposed to normally. That's the loading area where vials are loaded. So the vial washing is taking place right before they are loaded to the filling machine. So yeah, washing, and then they are going through the depyrogenation tunnel, which is set up at very high temperature, like 650 degree. So after washer, they're going to the depyrogenation tunnel, it says. Okay, so the vials are now going to the filling area. So there's a filling needles coming down, and it's dispensing the drug, and it's going up as it's filling to prevent the splashing of the drug. And those caps are the rubber stoppers. Okay, it's the stoppering. And sometimes nitrogen gas can be added as a stabilizer. Okay, sterilized stoppers are added. So it depends on if it's lyophilized or not. Different stoppers can be added. These are not lyo stoppers. So those you just saw was a lyo stopper. You probably just saw it. So if I play it again, see that those little channel? So yes, if it's going to go to a lyophilizer, they should have a little air ventilation channel on the stopper. So these are crimps that are placed on top of the stoppers. So the crimping is taking place right now. So all pumped in the isolator. So the crimping is taking place automatically. So that's the operation we're talking about here, okay? So going back to, the process. This showed you the vial filling after vial is washed and depyrogenated. And then this filling needle is coming down. So, and then it's going to dispense the drug, the formulated drug. And see that stoppering happening. So the needle is coming up. So hopefully the needle will not touch the opening of the glass vial. It's not going to make any drug molecule touch the opening, and then stoppering will take place. This is the rubber stopper, so we call the stoppering step. And yes, this can be used for lyophilization because you see that little air channel. So this stopper can be used for lyophilization, but if it's not lyophilized, then you don't have to have the channel. Okay? So once that stopper is pushed in, you can put a crimping. So tin aluminum, I guess, little cover is placed, and then it's pushed in. So there's a crimping operation. So we're talking about all this process as stoppering, filling, stoppering, and sealing operation. Okay, we'll talk about that. So sterile drug product filling operation. So it's very important. Okay, so how mechanically you can fill your liquid drug, especially if it's injectable drug. It involves a lot of engineering, okay, because it's totally automated. Okay, and then the characteristics of your drug matters as well. If it's a really heavy and viscous solution, it's hard to dispense the correct accurate amount, so there are some challenges about that. So all provide the repetitive forcing measured volume. Accurate measured volume should be dispensed into your vial. So that's necessary. So that's what it means. So the product surface tension, viscosity, and the temperature affects the filling operation, because if it has a lot of surface tension, it's really heavy and viscous, and depending on the temperature, that may increase. Then that will present a lot of challenge in the accurate filling operation. And then product could be dripping. Then dripping could make some inaccurate filling amount into the vial, so that could be another challenge. Okay. And when the machine is coming down, so the needle goes into the vial, and when it's filling up, it's moving up. So we call it bottom up. So the needle kind of moves. It's starting from the lowest position, and then it's slowly coming up when the drug is being filled. You do that to prevent any spillage or splash problem. Okay. And then if your drug is very heavy, viscous, and different filling mechanism can be used, a sliding piston or ton of auger, this kind of screw kind of motion. Those kind of things can be used, or oscillation of a rubber diaphragm. Those can be used to generate more force to push out your drug from the filling needle. Okay. So this YouTube video is probably showing you what is called as ampoule filling. So these are ampoules. So in the US, there are not that many injectable drugs that are packaged in the ampoules, but in other parts of the world, like Asian countries or European countries, they still do use these ampoules. So ampoules are kind of totally sealed glass vials. So then how do you feel? So ampoules come in like that with a long neck, and then you can fill in there. So after that's done, instead of placing a rubber stopper or seal, this long glass is actually flamed, kind of being melted, and it's pulled out, so it's going to be sealed. So ampoule is filled and sealed. So ampoule does not require any stopper or the crimps, because the glass will generate the filled container by itself. Okay, so you can take a look at that YouTube video. Here's that ampoule filling video, if you want to take a look at it. So these are the ampoule, kind of empty ampoules before they are being filled. An automated machine is pulling those in line, and then those are the filling needles, of course. Okay, so this is just a demo. It's not on the CGMP condition. It's just showing you how the machine works. Okay, see that flame, gas flame. So after filling is done, you can actually seal these ampoules. So you see that the filling operation there, needle is coming down and shooting out, dispensing the drug there. Okay, kind of out of focus, but showed you the automatic process. See that gas flame coming after that? It's a long elongated gas opening. The glass opening is being flamed, and then through the flame, and then grabbing and pulling, so the ampoules will be sealed after that automatically right there. Okay? So now see that those long glass neck is just pulled and sealed there. So pulling out, and the extra bit is taken off and just thrown away. So that's the ampoule filling and sealing operations. But the Catalan is not doing anything like this. You will not be able to find this operation in the US in the current days. Okay, so that's that. Let's go back to that. So, but understand what ampoule filling and sealing operation is. Those are called ampoules, and they may use this specially designed filling needles for ampoule filling, because they present better filling operation, because the metal chelating materials they can use. Okay, skip that. And then filling mechanism. So how do you fill accurately? That's a question, right? So the filling machines, they have different design and different mechanisms. So these are 4 different types of filling operations. So number 1 is gravity-based filling operation. So if you have a solid drugs or liquid drugs, they both can use this machine. So what you're going to do is, you place your drug high above a position, and then the gravity will pull them. So drug will try to travel to a lower position. So you will use that gravity as the main force to drive the drug into the filling machine. Okay. So then how do you control if you are filling the right amount, accurate dosage into each container, right? So that check mechanism is sometimes time pressured. Okay, you can generate how much is dispensed, and based on that you can accurately control the time, okay, to make sure accurate amount is being filled. Or you could use the weight check mechanism, okay, to see how much of drug is just added to a container, and see if it's the right weight or not. So that's how the machine can check and process the filling operation. Another possible filling machine operation is piston filling machine. Okay, so the machine will have pistons operating, at least a couple of them. So by pushing and releasing the piston, you can generate force. That force will, dispense the drug into the primary container. So you can use rotary piston or rolling diaphragm pumps. They will generate enough force to fill your drug. And then rotary pump, so another name for that is peristaltic pumps. So you probably seen that, and that's what you'll use in the lab when you do the aseptic filling operation. So it's relatively simpler, very much forgiving, because this peristaltic motion will generate the movement of the liquid into the primary container. Okay. And then finally, algo screw or vibrator, especially if you're filling solid drug, powder or solid drug, and then these filling machine with kind of screw type of movement can push your solid drug into the primary container. So there are 4 different types of filling machine. So gravity filling, piston filling, or peristaltic filling. And then if it's a powder or solid, you can use algo screw or vibrator. Okay, understand? 4 different types. So if you're talking about the gravity filling machine, like I said, simple design. Your drugs are placed on high position, and they'll come down through tubing because gravity is pulling them. And then you're going to place your vials there, and then needle will come, and then dispensing will take place. So since it's kind of naturally happening force, you can maybe control time or the weight, how much is being filled. That's how this machine will generate accurate filling movement. Okay, so it's very simple design compared to others because there's no moving parts in your filling machine much. Okay, and then it's cheaper. Okay, the design itself is cheaper. Okay, it doesn't require complicated engineering there. Okay, so this system can range bulk bag system working with about 1,000 kilogram or 1 ton size. So yeah, it is popular because it's simple and cheap. Okay. But there are some disadvantages of this machine. Okay, that is the dynamics of the fluid path and nozzle actuation characteristics continuously change over time. So since it's just set there, okay, and depends on how long you do the filling, so they don't just stay put. So they are being changed. So the accuracy may change. So you need to readjust that from time to time. Okay, so this requires the operator to make adjustment, okay, to the machine, the stored parameter more frequently than other filling mechanism. Okay, so although it's simpler, you have to adjust that continuously, and then automated check weighing with a consistent feedback to the filler control. If you have that mechanism added to your machines,